Bismillah ar-Rahman ar-Rahim. Inshallah, I'm going to do a small course about the distance protection relay, and this course will speak about distance relay zone setting. Then we will speak about blocking function in distance relay like power swing, VT fuse fail, and load encroachment. We will see this function and how it work and how it will be tested. Then we'll speak about the switch interfault. We'll see what's the purpose of the switch interfault. Then how will be tested and what zone need to be implemented the switch interfault. Then we will speak about some challenges that face the distance relay, like the underreach and overreach. Then finally we will go to speak about the communication scheme in distance relay, like DUTT, direct underreach transfer trip, and POTT, permissive underreach transfer trip, then POTT, permissive overreach transfer trip. But in this section, I'm going only to speak about the first in distance relay zone setting. First of all, you need to understand how the distance relay will work. Distance relay will work simply by measuring the impedance along the line. So to measure the impedance, as per the equation, Z will be equal V by I. So that's why in distance relay we need two input. One input VT and another one CT. We need VT to measure the voltage and we need CT to measure the current so we can get the impedance. And the distance relay normally it consists 4 zones. Zone 1, Zone 2, Zone 3 and Zone 4. Normally the setting in this zone, Zone 1, normally it will cover 80 to 85 percentage and the time delay will be instantaneous or 0 seconds. Zone 2, it will cover 120 percentage to 150 percentage with time delay almost 0.4 seconds. Between 0.2 to 0.4 seconds. And zone 3, it will cover 220 percentage from the line to 240 percentage and the time delay mostly they will use 0.8 seconds. And zone 4 normally it will use it as the reverse direction and it will use normally to protect or backup protection for the bus bar. So zone 4 will be reverse, and the time delay almost they make it 1.5 seconds and it will use as for the backup protection. So the zone 1 it will cover 80, let's say 85 percentage. This is zone 1. Okay. Zone 2 it will cover, assuming this is zone 2, it will cover like 150 percentage, and zone 3 it will cover this is zone 3, it will cover assume 240 percentage, zone 2 150 percentage, and zone 1 let's say 85 percentage. And most of us and many people they ask why zone 1 is covered 85 percentage. This is our main line from substation A to substation B. And why zone 1 is covered 85 percentage? Why not 100 percentage? Okay, now assuming now the zone 1 is protect 100 percentage. So now let's do some study cases if this scheme is happening. Now assuming the fault is happening here. If the fault is happening here, now the distance relay we will see zone 2, right? And if you check this, the fault is nearby the what? Zone 1. Now this CT and VT they have some error, right? This CT and VT they have some error because they are nothing in power system 100%. So this CT and VT, they have some error, and by mistake, the distance relay, we will see the fault in zone 1. So the relay will trip in zone 1, and this we know it as overreach. So the overreach was mean the fault point that the distance relay see, the fault point will be less than actual value setting for the distance relay. And this will speak more deeply when I'm going to speak about the overreach and the underreach. So that's why, because the CT and VT error, the distance relay will see this in zone 1. So that's why we'll keep it to 80 to 85% to avoid mal-operation for the distance relay. So now let's do some study cases for this single line diagram. Now, if the fault is happening here, simply we can say the distance relay will see the fault in zone 1, so we will trip in 0 seconds. Now, assume the fault happening here. Assuming now the fault is happening here. If the fault is happening here, simply the distance relay will see the fault in zone 2 because the fault location in zone 2. Now, this our main line. So why, if you check this in zone 2, so it will trip in 0.4 seconds, right? But this my main line shows, so I need to trip in 0 seconds because to get maximum stability in power system, we need to isolate the fault as soon as possible. So if the fault is here, is to my main line, so I need this to trip in 0 seconds. But unfortunately, the relay will trip in 0.4 seconds. So how to make the overlapping? So again, here in substation B, again we'll have another distance relay. It will take from the C to VT, and we have here another distance relay. And he will see this direction. So we have two relays, one from substation A and another one from substation B. And same things, this distance relay, it will cover zone 1 will cover 85%, zone 2 will cover 120%, and zone 3 will cover 240%. Same setting, but the direction will be like this. So, if the fault is happening here, the distance relay in substation B, we will see this fault in zone 1. So, we will trip this breaker at 0 seconds. But again, here we have another issue. Because this relay, he will see this fault in zone 2. So this breaker will trip in 0.4 seconds. See, any fault happen in my power system, I need to isolate the fault from both sides. So we need to both, this breaker both, I need to open in 0 seconds. This one and this one. So both breaker I need to trip in 0 seconds. So now, then we'll come to the communication scheme, DUTT and POTT scheme and POTT scheme, and this will speak about it in different section. And by using this scheme, so we can more understand about how to solve this issue and how this two breaker will trip in 0 seconds. Because this my main line, so I need both this relay trip in 0 seconds. This is the end of this section. I hope this video was very helpful for you. So inshallah, next section we will speak about blocking function. We will start about the load encroachment. Thank you so much.